Sri Gurubhyo Namaha. We welcome you all for our online project Ekalaiva. Today we are going to discuss solid state. CBSE Class 12. The lesson is solid state. We are aware of the solid state materials because the things around us, most of the things around us are solids. For example, the pen I am using is also solid, the remote and the board what we are using. So the things around us and the clothes we wear, everything around us are made up of solids only, solid state of matter. Now let us go in detail about the solid state materials. We are going to learn about the binding capacity and what are the different types of solids based on the binding capacity. All that things we are going to learn in this lesson, right? In the previous classes, that means in your lower classes, we would have learnt about the properties of solids generally and the different types of solids like crystalline solids, amorphous solids, stretchable solids, rigid solids, like that. And now in this class we are going to learn in detail about the crystalline and amorphous solids. Let us go to the topic. What are the things we are going to learn in this lesson? If you check, we have characteristics. We are going to learn the characteristics of solids. So the characteristics of solids we are going to deal with, and then types of solids, binding forces. What are the different types of binding forces acting over the particles of the solids when it is getting together, and crystal lattice. Of course, it is a new terminology what we are going to learn in this lesson. Crystal means it is nothing but every solid structure will be having a particular geometrical shape. Okay, in that the crystals will be having a cuboid structure. Actually, it is looking like a cube, right? So it will be maintaining a particular geometry. For example, it has 8 corners like this, right? And it has 6 faces. So we can fix up the solid particles in that crystal lattice so that we come to know about the particular geometrical shape of the solid materials present in it. Okay, and then packing efficiency of solids. Packing efficiency, what does it mean? Packing efficiency means it is nothing but the capacity of solid to hold the number of particles. How many particles can be just fixed in the solid crystal? Okay, that can be learnt in this topic. And then unit cell dimension. Unit cell dimension. Okay, and imperfections in solids. What are the imperfections? That means how the arrangement of particles in solid state will give the imperfections. Means the arrangement may be not regular in some of the solids. If it is not regular, what are the different types of defects can be caused due to the imperfect arrangement of the particles? So here we have some examples of solids where it shows how the solids can be. Because some of the solids are rigid in nature, some of them are compressible and some of them are stretchable solids. So here we are going to concentrate on 2 types of solids mainly. They are crystalline solids and amorphous solids. Okay, so crystalline and amorphous, if you mean, it may be actually made up of the particles which are compactly packed or loosely packed also sometimes. Okay. So here we have metal and cheese, the drum which is made up of metal, and chocolate. So these are all the solid state materials. First, when we talk about the solids, we have to go in deep about where the solid materials can be categorized. Okay, actually solid is a type of matter, right? We know that matter is nothing but anything that has mass and occupies space and has volume. So if I want to keep this pen, right, I need a surface to keep this pen. So it will occupy some space on the table. And if I keep this remote on the table, right, it needs some space, it occupies some space over there. So such type of matters are called as materials, and we can categorize the matter into three different types: solids, liquids and gases. In that particularly we are going to deal in detail about the solid state materials actually. If you look at the arrangement of the matters, three different types of matters, it shows that solid state matter, actually the particles are compactly packed, right, very tightly packed, they are close to each other. So which shows that the particles have strong attraction force between each other. Okay, so they are tightly packed and then they will be maintaining a particular geometrical shape. And the next thing is liquid. If you see, the particles are loosely packed, and in gaseous state the particles have random motion, they can move freely, right, and this is exactly the intermolecular structure of solids, which shows that how the particles are binding with each other with a strong attraction force. If you look at the structure, there are the different types of crystals. The long particle, that means the large particles are there, and short particles, small particles are also there. So the smaller particles are just embedded inside the larger particle, which means that if there are space in between the solids, and that space also will be occupied by the smaller molecules to make the structure to be very compact, and so it will be having a rigid structure, maintaining the rigid structure. So some of the characteristics already we have learned in our lower classes. Let us recap all the properties of solids now, the general characteristics. So the first thing, solids have definite mass. Actually every solids will have their own definite mass, and volume, shape, definite shape. So generally solid particles, solid materials will be maintaining a definite shape, and they occupy some space and thereby have mass and then volume. Then the intermolecular distances between the solid particles are so short, which means that the particles of solids are compactly arranged, they are very closer to each other, so that the binding force will be very strong. That's why they held together very tightly to maintain that rigidity. And the intermolecular forces of attraction between the particles are so strong, that's why the solid particles can maintain the rigidity. Okay, if the particles of solid are fixed, then what happened? They have the intermolecular forces of attraction between each other. That force of attraction keeps the particles of solid to be closer to each other, and the energy alone will be transferred from one particle to the other particle. The particles will not move in case of solids. There will be no movement of the particles. The particles will move, only the energy will move from one particle to another particle. Okay? And the constituent particles of the solids, it may be atoms or molecules, or sometimes it may be ions also. The charged particles, either it may be made up of positive and negatively charged particles together, or only positively charged particles will occupy, which can be called as a metal lattice. If the negatively charged particles are aligned together, then it is called as anionic lattice. And they have fixed positions, they can only oscillate, as I said. The particles will oscillate from the mean position and come back again to the original position. Okay, only the energy will be transferred from one particle to the other particle, right? And they are incompressible and maintain the rigidity. Rigid. Incompressible, which means they maintain the rigidity, cannot be compressed. If you take sponge, no, the sponge can be compressed, because the sponge is actually compressible solid which has some air, that means holes in it. So when the air is expelled out by compressing, right, it can be compressed. Okay. Next, the two main types of solids we have are crystalline and amorphous solids, and these solids are categorized based on the arrangement of the atomic particles present in it and binding energy, physical and chemical properties. Right? So how can we categorize the solids? Using the atomic arrangement, how the atoms are arranged, whether the particles are arranged regularly or they are in irregular arrangement based on that, and binding energy between the particles, and also physical and chemical properties of the particles. With all these categories, we can classify the solids into two main types. They are crystalline solids and amorphous solids. Now, if you take the two types of solids, one among them is crystalline solid. So, what are those type of solids actually? Solids which have definite geometrical shape. Solids which have definite geometrical shape, which means that I told you already they will be maintaining a particular shape, like they will be in a trigonal shape, okay, or like a cube, it may be like a rectangle, right? So, and maintain the sharp melting and boiling points. Usually crystalline solids will be maintaining a particular definite melting points at a particular range of temperature started melting, okay. And these are some of the examples. For example, if you take, this is a crystalline solid of rock salt, sodium chloride, okay, and then cesium chloride. All these you can take it as crystalline solids, and of course crystalline solids can be soluble in water, right? And crystalline solids, one of the most important property of crystalline solids, they shine in light and they are anisotropic. Again, a new terminology, anisotropic. We are going to learn in detail in the next class, okay. So, anisotropic in nature. So, crystalline solids shine in light and anisotropic in nature. So, the second type of solid is amorphous type of solids. Amorphous solids are actually fine powders. Their nature will be like fine powders like talcum powder and tooth powder, okay. They do not maintain the definite geometrical structure, and also they do not maintain sharp melting point, because like crystalline solids at a particular temperature, for example 109 degree means 109 degree it will be melting, the solid will melt. Such solids will be having the particular temperature as the melting point, are called crystalline solids. But amorphous solids will not be maintaining such melting point range, okay. So, with this we have some examples here, like starch powder, which is also an amorphous solid only, wax, which is also amorphous solid, and turmeric powder, chili powder, which is also amorphous in nature, okay. So, from this we can conclude the crystalline solids are very well soluble in water, but amorphous solids are not soluble in water. They just get settled down the bottom of the vessel or else bottom of the test tube, okay. So, such solids are called amorphous solids. Let us learn in detail about the crystalline and amorphous solids, properties and other things in detail in next class, children. Thank you. To get more videos, please subscribe our channel. You will get latest update. Thank you.